Hello grade 12s and welcome to this exam practice video on electric circuits. This question says, a learner sets up the circuit shown below to determine the EMF and the internal resistance of a battery. So we see in the circuit a battery with internal resistance. There is of course a switch called switch S. In series with the battery is an ammeter. This ammeter will measure the total current, I or IT, that is flowing through the circuit. In series with this ammeter, we see a variable resistor, also known as a rheostat. This is a resistor whose resistance we can change. We see across this variable resistor is a voltmeter, and this voltmeter is measuring the potential difference that the potential difference across the variable resistor. Since the variable resistor is the only resistor that forms part of the load in this circuit, we know that the voltmeter is going to be measuring V external. Okay, so now that we've analyzed the circuit setup, let's take a look at the information that has been obtained. They say the learner obtained the following graph from the data of the investigation. We see on the x-axis the current measured in amperes. Remember that on the x-axis of a graph, we plot the independent variable. This is the variable that we change. So this means that we are changing the resistance of the load, which is the variable resistor, R, so that we can control the amount of current flowing through the circuit. Okay, so current is the independent variable and it is being plotted on the x-axis. On the y-axis, we see potential difference measured in volts. This potential difference is the potential difference that is being measured across the variable resistor, and it is therefore V external specifically. It is not the EMF, it is not the internal potential difference, also known as lost volts, but instead it is the potential difference that is being provided to the load. When we take a look at this graph, we see that as the current increases, the potential difference decreases. While the current is called the independent variable because it is plotted on the x-axis, we see that the V external, or the potential difference, is plotted on the y-axis. This means that it is the dependent variable in this investigation. Let's now take a look at the questions. Question 8.1 says, state one factor that must be kept constant during the experiment. Provide a reason for your answer. Now, we are changing the resistance of the rheostat so that we can change the current. But remember, resistance is affected by one other thing, and that is temperature. So it is very important that we keep the temperature constant. And as a reason, we say that temperature affects the resistance. And of course, we don't want that to happen. You will state this in words, in full words. For now, I'm just writing it as a short answer. You're going to get 1 mark for stating that it is the temperature, and your 2nd mark for mentioning that the temperature has an effect on the resistance. Question 8.1.2 now says, what does the y-intercept of this graph represent? Well, we see over here that the graph shows a relationship between V external and the current that is flowing through the circuit. Whenever you are dealing with a grade 12 electric circuits problem, the following equation should come to mind. EMF is equal to V external plus V internal. We can expand this to I capital R, where capital R is the load, plus I small r. Now we know that in this investigation, V external is the Y value. We are plotting it on the Y-axis. And we know that the current I, which is over there, and of course is part of V external, is being plotted on the X-axis. So I'm going to rewrite this formula in the following form. EMF is equal to V external plus I small r. Okay, so I'm keeping this part as V external. So now we have Y is over here and X is over there. Let's rearrange this formula so that it is in the form or the standard form of a straight line, which is y equals mx plus c. We move V external over, divide by negative, and we find V external is equal to negative small r multiplied by I plus the EMF. From this, it is very clear that the Y value is V external, with the potential difference being supplied to the load. We see that the gradient is the negative, or is the negative version of the internal resistance. The gradient is negative the internal resistance. We see, as expected or as we wanted or intended, that X is the current. And lastly, we see that the y-intercept is the EMF. So question 8.1.2 says, what does the y-intercept of the graph represent? In order to answer questions like these, it is very important that you master manipulating equations as I just did. So practice this over and over again until you get it right. We can now answer this question and say that the y-intercept is the EMF, and that's going to get us 1 mark. Question 8.1.3 says, using the graph only. Now grade 12s, if they say only use the graph, it means that you're either making use of the area underneath the graph, or you're making use of the gradient, or perhaps a y or x intercept, but you may not make use of a formula. They say using the graph only, determine the value of the internal resistance of the battery. Remember, internal resistance has the symbol small r. Remember, by manipulating the equation, we found that the gradient is equal to negative the internal resistance. So that means that internal resistance is equal to the negative of the gradient, and we're going to write that down. From mathematics, we know that gradient is change in y values divided by change in the x values. We need to find two values, or take any two values off of this graph. Always ensure that you have the values, or that you take down accurate data points. Here at the y-intercept we have 0.6, and over here at the x-intercept we have 0.30. I'm going to make use of these data points, although you can make use of any others. So we say change in y, 0 minus 6, this value minus this one, over 0.3 minus 0. Don't forget, we are taking the negative version of the gradient, so we put a negative at the front. When we plug this into our calculators, work it out in our heads, we find out that the internal resistance is 20 ohms. You're going to get a mark for your substitution at the top and bottom, or you'll get a mark for substituting to find the gradient, 1 mark for your negative, and 1 mark for the final answer, giving you a total of 3 marks. Let's now take a look at the rest of the problem. Question 8.2 now reads, in the circuit diagram below, so this is a completely new circuit diagram, the EMF of the battery is 12 volts. So we're going to write down on the side, EMF is equal to 12 volts. The internal resistance is 0.4 ohms. On the side, we say R is equal to 0.4 ohms. The resistance of resistor 1, resistor 2, and resistor 3 are identical. Ignore the resistance of the wires and the ammeter. So we see the circuit setup. Notice that there are 2 switches, switch 1 and switch 2 in the circuit. We see that the 12 volts, which is the EMF and not the reading on the voltmeter per se, is given on the diagram, and we see that the internal resistance is written here as well. Very important is that if there is internal resistance given to us, then the EMF is not equal to the potential difference that will be provided to the circuit. So please be very careful and make sure that you use the correct values. Question 8.2.1 says, state Ohm's law. We say that Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. For writing that down, you're going to obtain 2 marks. I'm going to read that out again. We say the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Now we move on, and the question says, with switch S1 closed and S2 open, the ammeter reads 3 amperes. Fortunately, the sketch or the diagram shows S1 closed and S2 open. What we're going to do is we're going to go to the ammeter, and on the ammeter or next to the ammeter, we're going to indicate that the current is 3 amperes. Now they say calculate the resistance of the 3 or of resistor 3. That is this resistor over here. With switch S1 closed and S2 open, something different is going to happen from what we're used to. How about we make use of a thick highlighter, with the thick part of our highlighter and maybe it's a thin part, to determine how current flows in this circuit. We know current flows from the positive terminal of the battery. Here we're speaking of conventional current around the circuit. It's going to get to this point. Now, because switch S1 is closed, instead of the current flowing through resistor 1 and resistor 2, all of the current is going to take this path that has 0 resistance. We then get to the 3 ohm resistor. The current will flow through the 3 ohm resistor, resistor 3, and back to the other side of the battery. So based on this, it is almost as though if resistor 1 and resistor 2 have been removed from the circuit. And we can even erase this part as well, right? Because this is not doing anything for the circuit. And therefore, this is the diagram, the circuit diagram that we're dealing with. We notice that in this diagram, there's only one resistor, the resistor 3. Since there's only one resistor, it means that the current that is flowing through this resistor is equal to the total current, which is equal to the current that is flowing through the battery. So we know that the current flowing through the 3 ohm resistor is equal to 3 amperes. We are looking for the resistance of this resistor. We have the EMF and we have the internal resistance. So let's make use of this grade 12 formula that says that the EMF is equal to the total current multiplied by the load plus the internal resistance. The EMF is 12 volts. The current is 3 amperes. We do not know the value of capital R, which is the load or the resistance of resistor 3. And we know that the internal resistance is 0.4. When we manipulate this formula and we plug the values into our calculators, we find that the resistance of resistor 3 is equal to 3.6 ohms. Remember that these resistors are identical, so this means that the resistance of resistor 1, 2, and 3 are each 3.6 ohms. This question is out of 3 marks, so you're going to obtain a mark for your formula, a mark for substituting, and a mark for your final answer with the correct SI unit. Please never forget your SI units. Question 8.2.3 says that we need to now determine the reading on the voltmeter. This is still given that switch S1 is closed and switch S2 is open, so the circuit remains the same. The reading on the voltmeter is V external, and we know that V external is equal to the current multiplied by the resistance of the load. In this case, R3 is the only resistor. So we say the current is 3, the resistance we just calculated to be 3.6. Plugging this into our calculators, we determine the final answer to be 10.8 volts. You're going to obtain 1 mark for your formula, 1 mark for your substitution, and 1 mark for your final answer. The very last question says, both switches S1 and S2 are now closed. Please, grade 12s, always make sure that you read very carefully any information that is given to you in between questions, because the new information is going to affect the results or the answers that you obtain in the questions that follow. So going back to the circuit, we know that the circuit now changes. We can bring back resistor 1 and resistor 2, and we can close switch 2. Okay, so the question now becomes, what happens when we do this? And the best way I can explain what happens is by making use of a FET simulation. So over here is a FET simulation. At the moment, I have that, so please, none of these values are the same as what is on the question paper. I'm just using this as a simulation to show you how electron flow happens. We can use conventional current as well. This is the arrows represented as red, but I'm going to use electrons for this purpose. So we're going to close switch S1. And when we do so, we see that a short circuit is being created. And this is why in the previous problem, we ignored resistor 1 and resistor 2. Okay. Now, what happens if I close switch S2? Well, now we see that the current flows everywhere. Okay, and this can be a bit confusing. So yes, the values in this FET simulation are not the same as in your circuit, but let's use a voltmeter to sort of determine what is happening. If we place the voltmeter across the battery, we see a potential difference of 47 volts for this specific circuit. If we place it over the first resistor, we get 47 as well. If we place it over the second resistor, we still get 47. And over the third resistor, we also get 47. So this means that when we closed the switches as we did, we connected the resistors one over the other in parallel, because we know that in parallel, the potential difference is constant. Okay, so what we are doing is, if we go back to the circuit, we have the battery. There's the battery with its internal resistance. I'm not going to draw the dotted line around it, or maybe I should just get that done. So over there's the battery with its internal resistance. What we are doing is we're taking resistor R1, we're connecting across it resistor R2, and across that resistor R3. By closing both switches, this is the new circuit that we are forming. Okay, something like this. So now that we understand what closing the switches does to the circuit, let's on to the question that follows. Question 8.2.4 says, how will the reading on the voltmeter be affected? The voltmeter is over here. The voltmeter is measuring the external. Okay, so they ask, write down only increases, decreases, or remains the same, then explain. When you connect your resistors differently, the first thing that you're going to change is the external resistance or the load. So we can say that when we close switch S1 and switch S2, what we are doing is we are taking the resistance and we are increasing it. When we increase resistance in a circuit, we are not increasing the resistance, we're decreasing the resistance. My apologies, grade 12s. When you add resistors in parallel, the total resistance decreases. This is very, very important. When we add resistors in parallel, the total resistance decreases. Now, if the resistance decreases, then it means that the total current flowing through the circuit is going to increase. Resistance is opposition to the flow of current. So, if the resistance decreases, it means there's less opposition to the flow of charge, and therefore the current increases. Now we need to go back to the formula. E equals I capital R plus I small r. There are two values that are constant in this formula. Firstly, the EMF is constant, and secondly, the internal resistance is constant. So when the current value increases, what happens is that this entire value, the V internal, is going to increase, because a constant multiplied by a bigger number results in a bigger number. Now, if the value on the left-hand side is kept constant and this one increases, it means that the external, which is this value over here, is going to have to decrease. This over here is the external. So in the end, the correct answer to this question is it's going to decrease. It decreases. Okay, so when you state your reasons, you need to explain that the total resistance decreases, resulting in the total current increasing. When the total current increases, V internal increases, and as a result, we find that V external decreases. Whenever you are asked for an explanation, it is always best to give your answer in bullet point form to avoid confusing yourself, so that you know exactly what you're writing down to get marks, right? So this is out of 3 marks, so we know that we need at least 3 valid points. I started off by saying closing switch S1 and S2 connects the resistors in parallel. The total resistance therefore decreases. That gets you 1 mark. This causes the current to increase. That's the 2nd mark. An increase in current leads to a larger V internal or lost volts. That is the 3rd mark. And V external therefore decreases. And that gets you 3 marks and not 4 marks. I'm therefore going to award instead 1 mark for both of these bullet points, but normally a question that requires such a big explanation would be out of 4 marks. So make sure to master questions of this kind. Gr12, we've reached the end of this video. Thank you so much for joining me.